So welcome to all. Today we are going to start with the chapter number 4, okay, in your syllabus, that is energy economics. This chapter can also be called as financial management in energy conservation activity or conservation sector. Okay, so we will start. So first of all, we are going to see in this chapter, we are going to see what is the need of investment, why investment is required. Okay, this chapter mainly consists of the investment, then the different financial analysis techniques like simple payback period, rate of return of investment, net present value, internal rate of return, cash flows, risk and sensitivity analysis. Okay, that is what we are going to study in this chapter. This is concerned with the economical part of the energy management, starting from investing and ending up to implementation of some financial technical analysis. Okay, so we will start with the need of investment. So basically, why energy economics or financial management is required in an industry. Okay, so we all know that investment is the basic criteria for running of any organization or industry or any business. Okay, so we are going to see. So in the process of energy management, at some stage or at some level, investment would be required for reduction in the energy consumption of a particular process. Okay, so investment is required for reducing the energy consumption of a process or utility. So this is under the development part. Okay, so if you want to reduce the consumption of a process, okay, you require some material, or if you require some alternatives or require some alternative devices, for that investment is required. Okay, because money is required to purchase the thing. Then uh, here investment is required for modifications in the plant, also for retrofitting. So if you know the retrofitting, in case of electric vehicle, the term retrofitting is the conversion of a conventional petrol vehicle or fuel vehicle into hybrid vehicle. Okay, hybrid means running on both electricity as well as petrol. Okay, so there are different retrofitting kits available in the market for around 20,000 rupees. Okay, by using which we can convert our traditional Activa or Dio or Access, Pleasure, this kind of moped scooters into electric scooters. Okay, so what they are generally doing, they are replacing or they are just installing the batteries with a hub motor, okay, which is installed to your uh, rear tire, okay, back tire, and they are giving some controls in the front end, and then you can switch from hybrid to electric vehicle. And there are also some retrofitting devices which ensures a range of about 70 kilometer per charge. Okay, so for this kind of, so I have given you an example of retrofitting. So in case of industrial retrofitting, the investment is required. Okay, there are multiple retrofitting in investments industries. Okay, suppose there is an equipment like a boiler or different equipment. If it is an obsolete equipment, okay, if you want to purchase a new equipment, so rather than going to purchase a new equipment, you can go for retrofitting. Okay, then incorporating new technologies. If you want to incorporate new technologies, you have to make investment. For example, if you want to uh, install some solar panels, okay, at the roof of your industry, if you want to install some advanced exhaust fans, economizer, etc., so for that purpose you require investment. And also it would be prudent to adopt a system approach for merit rating of different investment options. Okay, that is the anticipated savings. Now also it is essential to identify that the benefits of the proposed measure should be captured in totality. okay, like direct project cost, then additional operations and maintenance cost, then training of personnel or new technologies, etc. And lastly, based on these above things, investment analysis can be carried out. Okay, now the cost involved, now these three factors, okay, are important when the cost involved, okay, in the investment. On what factor the investment should be given, like it should be given on the project cost, then additional operation and maintenance cost, and training of personnel, okay, training of staff and faculties on some new technologies. Okay, so now we are going to see what are the different financial analysis techniques, okay, that we are going to see. So before going to this, let us talk about the investment need. Okay, so to persuade your organization to commit itself to a program of investment in energy efficiency, you need to demonstrate first of all the size of the energy problem it currently faces, okay, then the technical and good housekeeping measures which are available to reduce the waste, then the predicted return on any investment, also the real returns achieved on a particular measures over time. Okay, now we are going to see this. Also, the need for investments in energy conservation can arise under some conditions, like for new equipment purchasing, for process improvements, etc., to provide training for the staff, to implement or upgrade the energy information systems. Okay, so that is basically the need of investment. Okay, now we are going to see with the financial analysis techniques. Okay, first is simple payback period. So before going to the financial analysis technique, I want to inform you regarding the cash flow. The term cash flow, basically that cash flow is important in case of all the financial analysis techniques. Okay, and the cash flow is nothing but the incoming and outgoing of money. So for example, incoming means whenever you are going to sell or produce some material, raw material, or design an product, then you are going to sell it, and whatever the profit that you are going to get, that is your income. Okay, incoming from the money. And outgoing means you are going to purchase the raw material and the equipments for that. Okay, that is the outgoing. So cash flow is nothing but incoming and outgoing of the money. hmm? So now we will start with the simple payback period. So basically, simple payback period is a measure of how long it will be before the investment makes money, actual money, and how long the financing terms need to be. Okay, so as it represents, okay, it is a first approximation, like the time required to recover the initial investment. Okay, initial investment is here first cost, considering only the net annual saving. Okay, so payback period is basically, suppose you have invested in a company. Okay, suppose the valuation of company is 100 crores, and you have invested 1 crore in that company. So basically you are having equity of 1%. Okay, and then how many time does it require for you to recover that 1 crore? Okay, either it may be number of months, number of years, number of decades. Okay, so that is the period that is called as simple payback period. In order to recover the cost that you have invested, that is the 1 crore, how much time is required? That is the simple payback period. Okay, so the formula is given: simple payback period equals to first cost, that is whatever you have invested, upon yearly benefits minus yearly cost. Yearly benefits, in order, like the profits from the industry, okay, whatever the profit they are making, minus the yearly cost is nothing but the operating cost, for which, for example, if you are going to produce 100 electric vehicle, okay, in a month, So how much energy is required to produce it, how much process and maintenance cost is required, operating cost is required to produce, that is the yearly cost. And the benefits are nothing but the amount that you have got by selling the electric vehicles. And the first cost is nothing but the investment, okay, initial investment for the project. So I think a simple payback period, it should be less, okay, it should be as less as possible. Suppose there are 5 to 6 projects, and if you want to choose any kind of project, you can go for the simple payback period. And when you are going to calculate the simple payback period of that project, and when you are going to compare the 5 projects, so whichever the project is having the lowest simple payback period, you can rely on that, you can choose it for investment. Okay, so they are given an example: simple payback period for a continuous deodorizer that costs rupees 60 lakhs. Okay, so here in this case there is a device called as continuous deodorizer, okay, that cost rupees 60 lakhs. So initial investment is 60 lakhs, okay, to purchase and install, okay, and 1.5 lakh per year on an average to operate and maintain. So 60 lakh is nothing but your numerator, that is first cost. Then 1.5 lakh per year is nothing but your yearly cost, which is in the denominator, and it is expected to save rupees 20 lakhs by reducing steam consumption. Okay, so here steam consumption is nothing but your yearly benefits. So by using the formula of simple payback period, you can get first cost what they have given, 60 lakhs, divided by 20, which is the yearly benefits, minus 1.5, okay, lakh per year, that is the operating and maintenance cost of the deodorizer. So it will be equals to 3 year and 3 months. So it will be quite 3.24 something. So you can round figure it to 3 years and 3 months. This is nothing but the simple payback period. Okay, so now we are going to see the advantages of this simple payback period. So this simple payback period is very easy, as we have seen. Okay, it has no constraint regarding the formulas, and it can be chosen in order to select some projects, okay, in a quick manner. So this is a widely used investment criteria, and it has some advantages like it is simple both in concept and in application also. So obviously by using this technique, simple payback period, if it is less, we can choose the project. If it is high, we can avoid, okay, so our money will be saved. So obviously a shorter payback generally indicates a more attractive investment, so it does not use tedious calculations. Okay, also it favors projects which generate substantial cash inflows in earlier years, okay, and discriminates against projects which bring substantial cash inflows in the later year but not in the earlier year. So as I said earlier, this simple payback period is mostly concerned with the substantial cash inflows that we are going to see here. Okay, this is explained in this table. So let's see some limitations. Now here there is a concept of time value of money. Okay, before going to the limitations, okay, we are going to see what is time value of money. Basically this time value of money is the present and future value of money. Okay, now for example, if the money can be deposited in the bank at at 10% interest, okay, suppose you are investing 100 rupees in a bank at an interest rate of 10% in 1 year. So after 1 year, what will be the value of that money? It will be 110, okay, 100 plus 10 rupees. So this 110 rupees in 1 year is the future value equivalent to the 100 present value. Okay, so what is the future value here? 110, and present value is 100. So in the same manner, okay, what is the time value of money we are going to see. So in the same manner, that 100 rupees that have been received 1 year from now is only 90.91 rupees. Now this 90.91 rupees is equivalent to the previous 100 rupees because of the inflation. Okay, so whatever, suppose you are investing 100 rupees in year 2018, okay, so that to 100 rupees in year 2019 or 20 will be having less value. Okay, so depreciation cost, consideration of inflation rate, that would be around 90.91 in today's money. Okay, so that means that 90.91 rupees plus 10% interest equals 100 rupees. So this 90.91 rupees represents the present value of 100 rupees cash flow occurring 1 year in the future. So if you are going to compare, 90.91 is the present value, 110 is the future value of the money. Okay, so this is the time value of money. Now if the interest rate with something different than 10%, then the equivalent present value would also change. So as we have considered interest rate as 10%, if it is 12%, then it will be changed. So the relationship between future and present value is given. Future value, okay, FV equals to net present value, or you can also relate between net present value equals to future value. Okay, so here I is the interest or discount rate and n is the number of years in the future. Okay, this is nothing but the time value of money. So here simple payback period, okay, it fails to consider the time value of money. Okay, so cash inflows in the payback calculation are simply added without suitable discounting. So in this case of simple payback period, the cash inflows, okay, in the calculations are only added without having some suitable discount and interest rate. Okay, this violates the most basic principle of financial analysis. Okay, now, okay, it also stipulates the cash flows occurring at different points of time, okay, that can be added or subtracted only after suitable compounding or discounting. Also, second disadvantage is that it ignores cash flow beyond payback period. Okay, so after payback period is over, suppose you have invested 1 crore, after when you are going to recover the 1 crore, the cash flows are being ignored by this simple payback period. This leads to discrimination against the projects that generate substantial cash inflows in the later year. Okay, now we are going to see the example. Okay, so to illustrate this example, consider two cash flows. Okay, cash flow A, cash flow B. So now for example, for this there are two projects, project number A, project number B. Okay, then investment on project is 1 lakh, on B also it is 1 lakh. Now we are going to see per year performance of the project. Okay, now here we can see cash flow of A or project A gives more earnings in the first 3 years. Okay, and cash flow of B means project B is showing substantial or constant cash flow, okay, returns in the first 3 years. So if you are going to calculate this, 50 plus 80, 100, so in 3 years the investment has been occurred, the investment has been collected for project A, but project B requires almost 4 years to recover this 1 lakh cost. Okay, but as compared to both, in the 4th and 5th year there is only 10,000 cash flow of the project A, but cash flow of B is substantially increasing in the later years for project B, that is fourth, fifth and sixth year. Okay, so it is giving tremendous. So in case of payback period, after getting the value or paying back of the investment, this is useless. Okay, so this is the limitation of the payback period. It discriminates. Okay, so that is the limitation. Now we are going, I have already seen the time value of money, and we are going to see the return on investment. Okay, this is also a very important part, return on investment. So this return on investment expresses the annual return from the project as a percentage of capital cost. Now example, if you are investing in a company, okay, startup, suppose you are invested 1 crore and the capital cost of startup is around 100 crores, so you are having 1% of equity in your pocket. So this return on investment, it indicates the percentage of capital cost. Okay, annual return from the percentage of capital cost. Like example, if you are getting 1 crore profit in 1 year, so 1% of capital has been collected by the startup, okay, of the capital cost for you. This is nothing but the return on investment. So the annual return takes into account the cash flows over the project life and the discount rate by converting the total present value of ongoing cash, okay, to an equivalent annual amount over the life of the project, which can also be compared to the capital cost. Now here return on investment does not require similar project life or capital cost for comparison. This is the main part. Now for example, if you are going to see the formula, return on investment equals to annual net cash flow upon capital cost, okay, into 100. Now this net cash flow, there are two types of uh, cash flow, like gross and annual net. So net is the actual cash flow and gross is the cash flow including the taxes and interest rate, okay, and depreciation cost, etc. Okay, so this is the formula for that, and it has two limitations. Okay, so it does not take into account the time value of money. Here also present and future value of money is not considered. It also does not account for the variable nature of annual net cash inflows. Okay, so net cash inflows has some kind of variable nature. Okay, it changes with respect to the time, so it does not account. Okay, what does not account? Return on investment does not account the variable nature of annual net cash flows. Okay, now we are going to see the next one, net present value. So this is we are going to see with the formula. So net present value of a project is equal to the sum of present value of all the cash flows associated with it. So basically it consists of sum of all the cash flow associated with the present value. So formula is given, NPV is the net present value equals to, not here, CF suffix 0 1 N. Okay, these are nothing but the cash flows. CF is the cash flow. For example, CF 0 is the cash flow of the year 0, then cash flow for the year 1, and times N. So summation, the formula important here is summation of T equals to 0 to N CFT upon 1 plus K to the power T. So this is the cash flow, this K is the discount rate, this T is nothing but year, okay, from 0 to N. Okay, N is the life of project. Suppose life of project is 5 years, so N will be 5. T will vary from 0, then 1, 2, 3, 4, 5, okay, and so on. Now we are going to see an example for that. So there is an example. So there is the investment of 10 lakh rupees in a project. So we are going to see how the cash flow or net present value works. So for the first year cash flow, okay, so incoming and outgoing of the cash is 2 lakh. For second year 2 lakh, then third year 3 lakh, fourth year 3 lakh, and fifth year 3.5 lakhs. So here the cost of capital K or the discount rate is 10%. Okay, now if you are going to put all this information, okay, with the value of K in this formula, we are going to get. So here use this formula CFT. Okay, so you can use this CF0. So what will be here? It will be the cash flow for the first year. So for the first year cash flow is nothing but, for the first year or the for 0 year cash flow is the investment. Okay, only the investment, it is only incoming. From the first year onwards it is in both terms, in incoming and outgoing. So you can write 10 lakh here, then 1 plus K. So 1 plus K is the discount rate, that is 10%. So it will be 0.10, 0.10 to the power 0. So it will be 1.10, 1.10 to the power 0. Okay, it will be 1.10 only. This will be also 1.10. So as you can see, for the first year 2 lakh is the cash flow, 10%. Okay, 2 lakh 10%. Again for the last fifth year, okay, 3 lakh 50,000 and 10% to the power 5. Now 5 is the life of the project, so it has 5 years project. So if you are going to see, it is 5,273. This is the net present value of the project. So now this net present value represents the net benefit over and above the compensation for time and risk. Okay, also the decision rule with associated with the net present value criterion is like that, is there is a quote: accept the project if the net present value is positive, and reject the project if the net present value is negative. So in this case, for this project the net present value is positive, so we can accept it. Okay, this is an kind of indicator, okay, what to accept or what to not accept. So advantages here is, so first is the main advantage, that is it takes in account the time value of money, okay, which is very important. So it takes present and future value of money. It also considered the cash flow stream in its project life. So this is the variation of cash flow it considers. Okay, likewise in case of return on investment and simple payback period, cash flow was not as that concern, but here net present value is considering the cash flow stream, okay, in the project life. Okay, so we are okay with the today's lecture. Okay, that's all for this lecture. From in the next lecture we are going to see the internal rate of return, then the example advantages, okay, then cash flows, what are the types of cash flows, and last part is the sensitivity and risk analysis. Okay, so take care, goodbye, I'll stop the recording.